Well, hello, boys and girls. How are you today? Are you having a great day? I am. So this is Mr. Broussard, in case you have forgotten my name. And we are here to do science, of course. We're going to do science together. And for the last few lessons, we have been discussing energy, kinetic energy, potential energy, what position has the most kinetic energy, what position has the less kinetic energy, what position has the more potential energy and the less potential energy. So we've been discussing all these things about energy. Well, today we are going to do a review. In fact, we're going to do 3 review lessons, okay? You know how sometimes you really know the content well, but then you get a test and you don't know how to answer those questions because the questions for the test are a little bit different. They are worded in a different way and you have to think a lot deeper, and it's almost like reading comprehension, right? So let me show you what our learning target for today is. So the learning target is I can apply the knowledge that I have about kinetic and potential energy to real life situations and justify my reasoning, okay? So today we're gonna be looking at some of those benchmark TCAP style questions, and we are going to go through all the choices and decide, apply that knowledge that we have already in our brains to those situations there that will be presented in the questions, and then we have to justify our reasoning. Why are we choosing that answer? Or why are we not choosing the other answers, okay? So we're probably gonna do 3 or 4 questions, okay? For each standard. So why don't we get started with the first question, right? So let's see what situation this question is presenting us, okay? Let's look at the first question. All right, so let's get started. So a student kicks a soccer ball into a goal. The speed of the ball is reduced when it hits the net. What conclusion can be drawn about the kinetic energy of the ball upon hitting the net? So I always recommend that you read the questions at least twice, okay? The first time you read it to sort of decode the words, and the second time and third time, possibly, you read it to understand what is happening there. So let's look at it one more time and let's create sort of like a mental picture of what is happening here so that we can understand the situation, okay? All right, so a student kicks a soccer ball into a goal. So there is a student. So let's create that mental picture. You can either put yourself in there or your friend or your brother or your sister. So the student kicks the soccer ball into the goal and the speed of the ball is reduced. So the word reduce, so it becomes less when it hits the net. What conclusion can be drawn about the kinetic energy of the ball upon hitting the net? Okay, so we have that picture now. The speed of the ball is reduced when it hits the net. What can we conclude? So let's look at the choices. The ball's kinetic energy decreases because its speed increases. So let's think about that. So the ball's kinetic energy decreases because its speed increases. So when the ball hits the net, does the speed increase or decrease? When the ball hits the net stops, the net stops the ball, so the speed is going to decrease. So that one cannot be. Let's look at this one. The ball's kinetic energy increases because its speed decreases. So if the speed decreases, we know that kinetic energy is energy in motion. So if the speed is decreasing, then we cannot have more kinetic energy. See, that's how you have to think about these things, right? Let's look at this one. The ball's kinetic energy increases because its speed increased. So did the speed increase? No, because it hit the net. So it cannot go faster. And then the ball's kinetic energy decreases because its speed decreased. So the kinetic energy decreased. So the kinetic energy became less because the speed became less. What do you think? Well, it just has to be the last one. It has to. And yes, it is the last one. So notice that we read the question a few times. We created a mental picture, okay? Created a mental picture in our heads. And then we went and we looked at each choice and see why that choice would be the right one. And when we found one that was not correct, why would that not be correct? Okay, so we went one by one and decided that is right or not right. And then we justified our thinking, okay? So I want to give you another one, and I want you to go through that process by yourselves, okay? So let's look at this question. So a student is pushing a toy car down a ramp. If the student places the toy car on the ramp again and increases the force used to push the toy car, what will happen? Okay, so first, let's read it one more time. A student is pushing a toy car down a ramp. If the student places a toy car on the ramp again and increases the force used to push the toy car, what will happen? So let's create a mental picture. We have to imagine a student putting a toy car on a ramp, right? And then we also have to imagine that when he put it again or she put it again, she pushed it harder. So now we have to figure out what will happen, okay? Based on what we know about kinetic and potential energy, what will happen? So let's read now the choices that we have. So the choices are the kinetic energy will increase and the toy car will go faster. Okay, so when we push the car, the kinetic energy will increase and the toy car will go faster. The kinetic energy will decrease. So remember, kinetic is energy that is in motion. Will decrease and the toy car will go faster. Choice number 3. The potential energy will increase and the toy car will go slower. And then the potential energy will decrease and the toy car will go slower. So what do you think? Make sense of that. What do you think will happen when the car is pushed harder? So pushing requires movement. That will mean that it's kinetic energy. So when you push the car harder, the kinetic energy will increase, will become more. And so the toy car will have to go faster. You see? Let's look at another question. And we got to have those thinking juices flowing fast and making sense of things and picturing things in our head and deciding, why would this be right? Why would this be wrong? Okay, so just put on those thinking caps. The next question is related to the rubber band experiment that we did a few lessons ago. Okay, so let's look at this one. And we don't even have to imagine this one that much because they give us a picture. So a student pulls the string of a bow to different distances and shoots an arrow. The student records the time the arrow takes to hit a target. Okay? And here is a table for that data. So distance stretch in centimeters is 5 centimeters, and then it took 4 seconds. 7 centimeters, 2 seconds. 9 centimeters, 1 second. Okay, let's see what the question is asking. So we know what's going on. There is a student that pulls a bow, okay, to shoot an arrow. So the question now is, what is the relationship between the speed of the arrow and its energy? So what's the relationship between the speed and the arrow? Okay, so let's look at number one. The arrow moves faster and has the most energy when the string stretches to 9 centimeters. So let's look at the chart. So 9 centimeters, 1 second over here. Well, let's keep looking just to make sure. The arrow moves slowest and has the most energy when the string stretches to 5 centimeters. So 5 centimeters is 4 seconds. The arrow moves slowest and has the least energy when the string stretches to 9 centimeters. Least energy. And the arrow moves fastest and has the least energy when the string stretches to 5 centimeters. Here is 5. Okay, so let's look at that one more time. So the arrow moves fastest and has the most energy when the string is stretched to 9 centimeters. 9 centimeters. It moves very fast because only 1 second. So if it's moving faster, it's because it has the most energy. Yes. So the answer is this one right here. The arrow moves fastest and has the most energy when the string stretches to 9 centimeters. It moves super fast, 1 second, and so it must have the most energy. Okay, so if you want to do a little review about kinetic energy and potential energy, you can watch a video, okay? You can watch a video. The title of the video is The Difference Between Kinetic and Potential Energy. So I'm going to post the link there. Your teacher can have it open for you, or you can open it yourself, okay? The name of the video is The Difference Between Kinetic and Potential Energy, okay? So the next lesson that we're going to do is going to be also going over some questions to make sure that we can apply the knowledge that we have about kinetic and potential energy to real life situations like the soccer ball or like the bow and arrow, okay? And see what is the relationship between what the knowledge that we have and what is actually happening in real life. So we always want to make sure that we can apply our knowledge to our school knowledge from the books, from the things that we learn, to real life situations, okay? That means that we truly understand it. So thank you, boys and girls, for joining me today. And these questions will not only help you make sense of science, they will also help you get a better grade on your science assessments, whether it is a classroom assessment or whether it is a benchmark assessments that are coming up soon in March, or whether it is a TCAP test that are also coming in the next few months, okay? So you always want to take the knowledge that you have and make sense of that knowledge, okay? Thank you so much. Have a wonderful day. Bye-bye. See ya.